Now the function I'm going to graph right here happens to be a hyperbola. A hyperbola has a negative sign, equals 1, and it happens to be an expression with a quantity squared with an x and a quantity squared with a y all over a denominator. Now, hyperbolas are actually pretty easy to graph, but you need to follow a few steps. First step you need to do is just like the other conics, is you need to find the center. Finding the center again is putting a value here that would make this quantity 0, such as x should be 3 and y should be 2. 3, 2. That's our center. From this point, what you're going to be doing is you're going to be making a rectangular box. Now how you make this rectangular box is pretty simple. It's kind of like graphing ellipses. You have to say to yourself, alright, how many spaces do I need to move in the x direction? I'm going to move 3. 1, 2, 3, and 1, 2, 3. Now how do I know it's 3? Because the square root of 9 is 3. It has nothing to do with the center. Know that. Okay, now in the y direction, hence you know you're looking at these with the y, how many do I move up and down? I'm going to move 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, because this is the square root of the denominator. These values right here, now don't connect them. What you're going to do is you're going to just use your graph paper and make this rectangular box. The idea behind hyperbolas is that you are able to create what are called slant asymptotes. So the slant asymptotes are diagonal asymptotes, and the definition of an asymptote means you can't touch it whatsoever. So diagonals always go through the center. So when you connect your diagonals, make sure you're going straight through the center. And I'm not using a ruler. I recommend you do. But just to get through this, here we go. Alright, so I've made 2 diagonals. Okay, so that was step 2. Make 2 diagonals. All of these are dotted, by the way. So I guess we'll put that in the directions. Make sure it's dotted. Make sure it's dotted. Okay, because that's not really your function. Your function is going to be 2 what are called branches. They look like parabolas that you're going to go up and down x and make an x, or up and down and make a quantity like this. Now, here's the technique I teach students to remember. There are 2 types of hyperbolas. One type of hyperbola looks like this. Okay? The other type of hyperbola looks like this. Now, which one are you using? It all depends on what value you're starting with. I'm starting with an x value, so I'm going to be using this one. The technique I do is I kind of hide this, and I draw a little line and I say, this looks like an x, this looks like a y. So if it starts with an x, you're going to graph a hyperbola that goes left to right, which is called a horizontal hyperbola. And if you start with y, which we didn't, you would be having this up and down version, which is a vertical hyperbola. But that's the technique I show students to help remember which version you're doing. So since we already know it's going left and right, we're starting with x. We're going to put this all the way to the edge of the box. Notice I started at the center, went to the edge of the box, center, went to the edge of the box. And then based on the definition of asymptotes, I say, let's get really, 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 really close to this dotted line, but never touch it. Same thing over here. Get close to it, never touch it. Get close to it and never touch it. Get close to it and never touch it. So that's how you graph your hyperbola. You don't need inputs and outputs to do so. Obviously, that would make it more accurate, but it's a beautiful graph, easy to do. And as you can see by the work I've shown, there's not much work to show once you have it in this standard form.